Good afternoon, happy Sunday to everyone. I hope you all have had a good week. I know this is the beginning of a new week. I hope you had a good weekend, you enjoyed your weekend, you got a chance to go out and do something exciting. I know we're always watchful of what's going on with COVID, but I'm sure you were able to do something in the backyard or something fun. I know I got a chance to play some soccer with the kids last night or in the evening yesterday, and that was exciting. And so we're getting ready for a new week, and we want to make sure that if you're a student, and I know some of us are virtual, some of us are hybrid, and some of us are going in person. But if you have any topics that you struggled with in the previous week, or that or you think you need help with as you prepare for an upcoming test, this is your opportunity to share with us. We're going to learn together. I have some questions already prepared, but if you have more pressing topics, I will always prioritize those over what I have already prepared. So let's get started. We're going to wait for a few minutes for people to just come on in, and then we will just get this moving. We're going to go for about an hour or so today. But if we need to spend a bit more time because people have questions, at the end of the day, we want to make sure that your needs are being met. So feel free to send us questions. If I post a question out here and you're not sure what to do, also let me know that you need some help. But if you know what to do, go ahead and try. It may also be an opportunity for you to, sharpen up your skills as you prepare for a new school week. Or maybe you may be having tests, so this is a good chance for us all. So let's go ahead and we'll get started. I have some questions. I will post the questions. I'll give you a chance to answer. And if you need help with anything, meanwhile, post them in the chat, and I'll be happy to get those questions answered for you. Thank you for joining us. I know you could be in so many other places right now. Thank you. We appreciate the fact that you're honoring our invitation to join us for a session of math this evening. I want to also remind you all that on Mondays through Thursdays, in addition to our private sessions, we actually have free sessions available to students. It's typically starts about 3:30 and sometimes goes to about 5:30. And so if you are having struggles with your work during the week, and you may be a student that is has private sessions, but you may be needing help outside of your private sessions, this is an opportunity for you to get help. The private sessions on Zoom, so you can get a chance to actually ask questions of the tutors that are going to be working with you during the free sessions. So our free sessions are on Zoom, just like our private sessions. We want you guys to have an opportunity to interact directly with the tutor that will be running the private sessions. All right, so we have our first question of the day, and it's multiply 25.4 by 4.23. And the reason why I have this question is even for some of our private students that we have, I'm also bringing out topics that are relevant because we're looking at some of the topics that maybe they struggled with or they wanted some help with during the week. And we want to also because we just imagine that a lot of other students may be having the same struggles because our students are not just within our local community. We have students outside of the state that we live, and that's giving us an opportunity to get a sense for what students across the country may be struggling with. So a lot of our live sessions will be either student requests or just observations that we've made throughout the week of topics that students need help with. And so we'll do that here, and it also gives a chance for us to kind of learn together. But remember, if you have anything that you want us to work on, if you have a topic, if you're preparing for a test and you need some help just refreshing some topics, or you have homework that is due on Monday and you need a final opportunity to get someone to explain it to you, this is that opportunity for you. I want you to take advantage of that. So let's go ahead and start with the first question. We are multiplying 25.4 by 4.23. With a question like this, the reason why this is an important question for us to examine is most students can really do the multiplication. The problem they have is the decimal placement. So I'm going to teach you a method that I've used for students for so many years, for probably close to 2 decades, and it's actually helped them become very successful in multiplying decimals. So I'm looking forward to hearing your answers. If you know this, feel free to answer, and don't feel shy about being wrong. This is not the place for you to feel shy about being wrong about your answer. If you're wrong, we appreciate the fact that you actually made an effort in trying to solve the question, and we'll be happy to kind of go through it together. So let's give a few more moments on this, and then we'll go ahead and solve the questions together. Okay, so let's go ahead and answer the question. Maybe students may be shy about answering the questions. So let's go ahead and answer the questions together, and if you have questions as we solve the questions, feel free to let us know. Alright, so I'm going to show you the method that I find to be the most reliable method whenever you're trying to multiply decimals. And this is how we're going to go about it. I'm just going to write the numbers. 25, I'm going to write the numbers without the decimal first, because sometimes students make the mistake of trying to line up the decimals with multiplication and division. You don't have to. That's only important when you are dealing with addition and subtraction. So I'm just going to write 2, 5, 4, and then 4, 2, 3. And then we're going to multiply. So what I'm going to do now that I've written out the numbers, I'm going to put the decimals. So I have a decimal right here, and then I have a decimal right here. So let's go ahead and perform the multiplication. So we have 4 multiplied by 3. That's going to give us 12. So we're going to write 2, and we're going to bring 1 up here. 5 multiplied by 3, we have 15. We add 1 to that, that is 16. We're going to write 6 and bring 1 up here. 2 multiplied by 3, that's 6 plus 1, we have 7. So now we're done with this number in the bottom row. So the next thing we're going to do is we're going to focus on 2. So what we need to remember whenever you're multiplying, because 2 is in the tens place, you'll know that every number that is in the tens place ends with a 0. So we're going to put a 0 right here. I know a lot of students just add a 0. They're not quite sure why they do. But the real reason why you add a 0 at the end is because you're multiplying by a number in the tens place, and a number in the tens place always ends with a 0. So 4 multiplied by 2, we have 8. 5 multiplied by 2, let's cross this off since we don't need them right now. 5 multiplied by 2, we have 10. So we're going to write 0, and we're going to bring 1 up here. 2 multiplied by 2, we have 4 plus 1, we have 5. Okay, so now we're done with the number in the tens place. Now let's go to the hundreds place. Every number in the hundreds place ends with 2 zeros. So we're going to add 2 zeros here, and then we're going to go ahead and multiply. 4 multiplied by 4, we have 16. So we're going to write 6 and carry a 1 up here. 5 multiplied by 4, we have 20 plus 1, we have 21. So we're going to write a 1 and carry a 2 up here. And then 2 multiplied by 4, we have 8 plus 2, we have 10. So I'm going to write a 0 here and a 1 here. And now a good practice for you as students is when you get to this point. Okay, I see some answers. All right, fantastic. Is the one is okay? Let's go ahead and see whether you are all right, and if you find any errors in what I'm doing, also feel free to point that out. So we're going to just, what I like to do is I like to replace every empty space with a 0. just so that it's easy to add up the numbers. When you get more experience, you don't have to do this. It's just a good habit to form anyway. So now we're going to add all the numbers together. 2 plus 0 is going to be 2. 6 plus 8 is 14. We write a 4 and we bring a 1 up here. 1 plus 7 is 8. Plus 6, 14. So we write a 4 and bring a 1 up here. 1 plus 5, 6 plus 1, 7. You have 0 plus 0 plus 0 right here. 0 plus 0 plus 1. We have that right here. So now we're done with the multiplication. The next thing we need to do is figure out where the decimal point needs to go. How do we do that? Here's my method. You're going to count the number of digits after the decimal and just sum them up. So look at this right here. We have only one number after the decimal. I'm going to write a 1 here. I have two numbers after the decimal. I'm going to write a 2 here and just add them up. And this is going to give me 3. If you have more than two numbers you're multiplying, you can also apply the same method. So this method works all the time. So now we have 3 decimal. It means that the decimal digit is going there. You have to have 3 digits after the decimal. That's what that number really means. So we're going to count from here. We have 1, 2, 3. So the decimal is going to sit right here. So our answer is going to be 107.442. Very well done. Well done to those who answered. Jaden, Anastasia, well done to that. Well done on that. So are there any questions? I hope this is clear. Let me just recap the method. First of all, you're going to write the numbers without the decimal. After you've arranged the numbers the proper way, you go ahead and place your decimals. And then after you will go ahead and perform your multiplication. But when you multiply, ignore the decimals while you're multiplying. Then right after that, you want to count the total number of decimal digits you have. So you're going to take the number of decimal digits from each number and add them up together. And then you want to make sure that that number you get is the number of digits you should have after the decimal point. And that's the method. This method is the most reliable method that I've seen used. So let's go ahead and try the next question. Let's go to the next question. So here we're looking at performing order of operations on positive and negative integers. So this is one of our Pemdas questions. So this is going to be Pemdas. This is one that a lot of 6th graders are probably either just finishing or about to finish, most likely writing some some tests or quizzes as they try to finish up the topic. So this is just a chance for us to take a look at it again. So we're going to look at Pemdas. This is going to test your understanding of order of operations using Pemdas or Gemdas or Pedmas, depends on what your school uses. And you're also going to test your understanding of how to add, subtract, multiply, and most likely divide positive and negative integers. So we have 2 squared plus negative 9 divided by negative 10 minus negative 5 multiplied by negative 2 to the power of 3. So we have parentheses, we have exponents here, we have multiplication, we have division, we seem to have addition and subtraction. So this is perfect. This is a good way to test all that you know about Pemdas. So I'll give you a few more moments to try to answer this question and then we'll try to do it together. Whenever you have a question that has several operations, always remember that your order of operations is what rules the day. That's what's going to give you your guide on how you should proceed. Don't feel bad if you don't have the right answer. Just give it a try. This is always an opportunity for you to keep learning. We're here to learn. I'm here to learn from you. You may have a method I've never seen before. That is the beauty of math. One of the great things about math is there are lots of different ways to get to your destination. And I'm always open to hear other methods that I haven't seen or I've not thought about. And so it's what makes math, you're always learning whenever you're working with math. Okay, let's see. Do we not know what to do? I can see there are no responses yet. Anybody need some help, or anybody working on it and need some more time? Okay, so let's go ahead and walk through this, and I'll show you the simplest method to approach this. We're looking at Pemdas here. So we look for, P stands for parentheses. So let's see if we have any parentheses here. We have this one here. We have this one here. And I guess you could look at this as one of them, but not that important just yet. So instead of the parentheses, we need to figure out we need to simplify. When we talk about parentheses, we're looking to simplify the content of the parentheses. So let's start from the left to the right, since we have several parentheses. We have 2 to the power of 2, so 2 squared is going to be 4. And then when you have a positive parenthesis negative, the negative will always come out on top, so you have minus 9. And then we are going to divide. And then we have another parenthesis here. So we have negative 10. And then you have minus parenthesis minus. So this is going to end up becoming a positive. So plus 5. And then we multiply by negative 2 to the power of 3. And I'm doing it this way just because I want to follow the order of precedence, or the order that you should solve this question. So now we're going to go ahead and simplify what's in the parentheses, because we need to make sure that the parenthesis no longer is there. So 4 minus 9, what you do whenever you have to add, whenever you have to solve positive and negative integers where the signs are different, especially when it's addition, subtraction. Whenever the signs are different, you're going to subtract the numbers first. So 9 minus 4 is going to be 5. And then we're going to look at the sign on the larger digit. The larger digit is 9. The sign on that is negative. So we're going to have that divided by, and then right here we have the same situation. 10, negative 10 and positive 5. So we're going to go ahead and subtract. So that's going to give us 5. And then we have the negative sign is on the larger digit. So I'm going to make this negative 5. And then multiplied by, so we have, now that we've dealt with the parentheses, we can now deal with the exponent. So this is going to give us negative 2 to the power of 3. Negative 2 multiplied by negative 2 multiplied by negative 2. One of the things to remember is that whenever you have a negative number and the exponent is an odd number, your answer is always going to be negative. So let me repeat that. If you have a negative number and you have an exponent that is odd, your answer is going to be negative. If your exponent is even, your answer is going to be positive. So this is going to give us negative 8. So now we have division and multiplication. So one of the mistakes that students tend to make with Pemdas is they believe that whenever you have MD, the multiplication must always come before the division. Not true. This is treated as a group. Multiplication and division treated as one group. Addition, subtraction treated as one group. And the reason why is that if you have a question where you have multiplication and division in that question, you're always going to look at the operation that comes first from the left to the right. Multiplication isn't always going to take the order of precedence. Don't fall for that. You always start with the operation that comes first from your left to your right. So here, if I look at this, division comes first. You can see that it's not even, so you can see division comes first. So we're going to take care of that. We're going to have negative 5 divided by negative 5, and then we multiply that by negative 8. This is going to give you 1 because what we know in math is any number divided by itself is 1. 1 multiplied by negative 8, this is going to give you negative 8. Now what I like to do sometimes as we walk through this is I want to show you why the other method necessarily may not be the best thing. So if we had treated it as multiplication comes first before division, here's what we're going to end up. We're going to end up with negative 5 divided by negative 5 multiplied by negative 8 is going to be 40. So negative 5 divided by 40 is going to give you negative 1 over 8. This is why it's important to make sure you understand the order of precedence, the order of operations of all these mathematical operations. So answer here is negative 8. Okay, good job, Anastasia. Looks like you got that. Negative 8 is very correct. Very good job on that. Okay, now we have next question. Are there any questions on this? Any questions? Okay, let's go to fractions. So we have 5 1/3 minus 2 1/4 divided by 1 1/5 plus 2 1/2. So we're going to solve the numerator first, then we'll solve the denominator and then divide the results by each other. What I wanted to do was an opportunity to put all of our main order of operations with fractions together: addition, subtraction, multiplication, and division. So give this a try. I'll give you about maybe 2 minutes because this may be quite involved. You can actually go ahead and convert each of the mixed numbers to improper fractions and work that way. It's pretty simple that way. Convert all your mixed numbers to improper fractions and then solve them. That would be a lot faster. And then I'm going to show you a method that I think I had shown. I did not realize that a lot of students did not know this method. I had some, I tried it out with some of my students this week and they had never seen it. So I'm going to also introduce you all to this method and see how you like it. Okay, how are we doing with these fractions? So first of all, I want you to go ahead and convert this to improper fractions and then use those numbers, those new fractions you've got, use them for your addition and subtraction. That will be a lot faster. Okay, so let's go ahead and try to answer this together. So the first thing we're going to do is to convert each of these mixed numbers. We're going to convert each of them to improper fractions. And to do that, what you're going to do is multiply the whole number by the denominator and add the numerator. That's all you have to do for that. So we have 5 1/3. So we're going to convert this to an improper fraction. So we have 5 multiplied by 3, 15 plus 1. We have 16 over 3. So I'm going to rewrite this question just using the improper fractions. So we have 16 over 3 minus 2 multiplied by 4, 8 plus 1, 9 over 4. And we're going to divide by 1 multiplied by 5, 5 plus 1, 6 over 5, plus 2 multiplied by 2, 4 plus 1, 5 over 2. So now this is the question we have with all the numbers, all the mixed numbers converted to improper fractions. So let's go ahead and remember our method, or the method for adding or subtracting fractions, is to make sure that your denominators are always the same. Your denominators need to be the same for you to be able to add or subtract fractions. So here we have 3 and 4. We can simply use 12 as our new common denominator. And to do that, we need to rewrite each of the fractions such that their denominator is 12. So here I'm going to just keep some space here for some rough work. 16 over 3. For me to get 3 to 12, I'm going to multiply by 4, and I'm also going to multiply by 4 here. This is going to give me 64 over 12, and then I have 9 over 4. I'm going to multiply by 3, multiply by 3, so we have 27 over 12. So this is going to be 64 over 12 minus 27 over 12. So now let's go to the denominator. We have 5 and 2. We need to get to a common denominator. I'm going to use 10. 5 multiplied by 2 is 10. So we're going to simply rewrite each of these improper fractions so they have 10 as their denominator. So 6 over 5, we multiply 5 by 2, multiply 6 by 2, we have 12 over 10. And then we have 5 over 2. We're going to multiply 2 by 5, and then also multiply. We're also going to multiply 5 by 5. So we have 25 over 10. So now we're going to simply have 12 over 10 plus 25 over 10. Now that we've done all of this work, we just simply, because we have a common denominator, let's go ahead and just subtract the numerator. So 64 minus 27 is going to give us 37. And then we're dividing that by 12 plus 25 is 37, and we have a common denominator of 10. So now we're going to go ahead and do some division. Whenever you're trying to divide a decimal, here's the rule. You're going to, let me rewrite this fraction so that it looks like a division question. So this is going to be 37 over 12 divided by 37 over 10. So what we're going to do is we're going to leave the fraction to the left of the division symbol. We're going to keep it the same. So that is going to be, this is going to be equal to 37 over 12. Then we're going to change the sign from a division to a multiplication. And then we will switch the position of the numerator and denominator. So that simply means 10 is going to become your new numerator and 37 is becoming your new denominator. So this is going to be 10 over 37. So this is what we're going to simplify. Now that simply means for us, I can go ahead and say 37 multiplied by 10 over 12 multiplied by 37. Some may want to go ahead and multiply it across. You could, but I think it will take a lot more time than the method I'm about to show you. So 37 is up here and 37 is down here. So you can see that we're simply saying 37 divided by 37. So this is going to cancel out. And now we're left with 10 over 12. We can simplify by dividing by 2. And we have 5 over 6. So the answer to this is 5 over 6. Now let me show you the other method that I was speaking about earlier when it comes to adding and subtracting decimals. For that method to work the best, you have to have everything as improper fractions. So here's what the method looks like. So 16 over 3 minus 9 over 4. You can simply cross multiply that way. So you have 16 multiplied by 4 minus 9 multiplied by 3. And then we're going to multiply the denominators across. 3 multiplied by 4. So this is 64 minus 27 over 12. You can see we get back to exactly the same thing. So that's the method. You can always use that to check whenever you're working through fractions and you're not quite sure if your answer is correct. You can use that to cross-check your answers. So the answer here is going to be 5 over 6. I want to also let you all know that I know that fractions is a topic that challenges students from all ages, all levels of education. So what we've done is we've put together this workbook that allows you to walk through fractions from the elementary level all the way to the advanced level. You can find it right now on Amazon. It's available on sale on Amazon all over the world. Wherever you can get an Amazon, this book is available for you to buy. The idea behind this book is that once you have this book, whenever you see fractions, it should never scare you again. You should never find it difficult after you go through this book. It goes through everything from how to identify fractions to the different ways to add fractions, subtract fractions, multiply and divide fractions. And you are also going to have some word problems as well. The book is structured in such a way that we introduce the topic, we show you the different steps that you should follow to be able to answer the fraction questions. Then right after that, we give an example showing you how those methods are applied. All those steps are applied for the method. And then right after that, we have some questions that we call guided steps. So we're going to use the steps that we've given you and we're going to show you exactly how to apply it on your own to some questions. And then finally, for every topic, you'll have some free response at the end of every topic. So this is a way for you to feel that you understand the topic, because we believe strongly that in math, the more practice you get, the more you can repeat the steps, the easier it will be for you to get it memorized. Actually, to become a part of your approach to solving that type of a question. So feel free to go on Amazon. Amazon is selling it right now. We have quite a few people already buying, and I think we have some comments, some reviews. The reviews have been quite good so far, and we have most of the people that have purchased it have given us positive reviews, even word of mouth. So we know that this will be a book that would help you tremendously in improving your understanding and your approach to fractions. Once you purchase the book, give us some feedback, let us know. You can send us an email, go on our YouTube channel, let us know what you think about it, if there are any areas that you need us to maybe help you out, understand fractions even better. But I can guarantee you that once you have this book, it has the answer to anything you want to know about fractions. Okay, let's go to the next one. This is for our students that are in Algebra 1 or Grade 8 Math, or also Grade 7 AP, Pre-AP Math. This is a topic you're going to find. Find the length of the line that joins the points -9, 7 and 4, -3. Find the length of the line that joins those points together. I'll give you an idea. This is what we call the distance formula. It's the distance formula. You always have to remember that. And the idea behind the distance formula is that if you have a point here, you have another point over here, the line that joins them together is going to represent a distance that you can travel from that point to that point. So that's really the idea behind that, and I'll give you the distance formula so you can use that to help you. The distance formula, if you have 2 points, and if you have 2 points, x1, y1, and x2, y2, The distance between these 2 points is given as the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's going to be the distance between those 2 points. All you have to do is figure out which ones you want to be x1 and y1, and which of them you want to be x2 and y2, and then just substitute those numbers into the formula. Any questions for the topics that we've covered so far? Are there any questions? Or if you're joining, welcome to our live chat, our live streaming today, and we're just helping students answer questions in math that they may need to prepare for the new week, or to kind of help them make sure that they feel good about what they have covered in the previous week. So that's what we're here to do. We want to make sure that we can help you answer your questions. And I also want to remind you all that Mondays through Thursdays from about 3:30 p.m. Central Standard Time, we have free sessions on Zoom that you can be a part of. In those sessions, you can ask questions about your assignments. You can ask questions about your tests. In fact, we had a breakthrough last week. We had one of our students that is a private student actually join one of those sessions to help prepare for an exam, for maybe a test, and she was able to use that opportunity, and she scored about 100% on her test. So this is what I want you guys to realize, that we're trying to make these avenues available, because our goal is to see how we can help 5,000 students at the end of this school year improve their grades in math. We have a campaign called 5K for Math. We want to help 5,000 students improve their grades, and those that have pretty good grades, we want to challenge them to even aim higher in their math education and in their math experience. So join us, join these Zoom sessions. We have those for free. We also have our private sessions that you can ask us about if you don't like group settings, because we have students that don't like the group settings. They prefer more of a private or a very smaller setting. So we have that option also available for students that prefer that option. All right, let's go ahead and answer this question. So we're looking for the length of the line that joins these points together. The first thing I like to do here is I want us to identify x1 and y1. So I'm going to just use x1, y1 here, x2, y2. So now we're going to go ahead and substitute all of these values into the equation I gave you earlier. So you're going to have the distance between these 2 points is going to be the square root of x2 minus x1. So that is going to be 4 minus negative 9, and we're going to square that, plus y2 minus y1. y2 is negative 3 minus y1 minus 7, and we're going to square this. So let's go ahead and continue to simplify. 4 minus negative 9, that's going to be 4 plus 9, so that is 13 squared, plus negative 3 minus 7. Whenever the signs are the same, you're just going to add the numbers and keep the sign. So this is going to be negative 10 squared. And so let's go ahead and continue to simplify this. We're going to have 13 squared is 169, plus negative 10 squared. Remember, it's a negative number with a positive with an even exponent. So because it's an even exponent, we're simply going to make sure that we're simply going to have a positive number for our answer. So it's going to be 10 squared, which is 100. So this is going to be the square root of 269. The square root of 269. Now, D is the square root of 269. You have two choices, and it all depends on the way your answer is expected. If your answer is expected as a radical, this is perfect because 269, most likely I think it's a prime number. So you can't really simplify it further. So 269, or if your answer, if the question you're given requires you to write it in a decimal form, you would go ahead and put this in your calculator and then provide an answer to the nearest tenth, hundredth, or thousandth, depends on what your teacher is expecting of you or what the question is requiring of you. So this is going to be our answer. D is equal to the square root of 269. So let's go ahead and actually change that to, let's go ahead and write that as a decimal. So I'm going to write this as a decimal, 269, and then the square root of that. So we're going to have 16.401 to the nearest thousandth, but we can simply say this is going to be equal to 16.40, let's do it here, 16.40, and then I'm just going to say to the nearest hundredth. I can put that in parentheses. So that's really all you have to do for this question. Alright, let's go to the next question. This was a question that was asked of us last week, and so we get another opportunity to answer this. We're looking at simplifying complex numbers. Simplifying complex numbers. A complex number is a number that has an imaginary number and a real number combined. An imaginary number is the one with the I, and your real number is any number that you can find on the number line. So we have 4 minus 3i divided by I minus 2. Give this a try and then we'll get to it together in a second. Alright, how are we doing with this? So simplify 4 minus 3i divided by I minus 2. 4 minus 3i. So here we're looking at something called rationalizing. We're rationalizing complex numbers. The idea behind rationalizing is, in math we generally do not like to have radicals or complex. We don't like to have radicals or imaginary numbers in the denominator. So the purpose of rationalizing is to find a way to make sure that the number in the denominator is a real number. Most times we like them to be integers. If you have any questions about what we're working through, please let me know, and I will be glad to get other questions that will answer the topics that you're interested in. So let's go ahead and try to simplify this. Whenever you're trying to rationalize, you're going to focus on the denominator. That is really the area that is really the part of the fraction here that we need to tweak or we need to modify. So whenever you have to do that, you're looking for the conjugate. There's this term called the conjugate, and the conjugate is a term that you will multiply these denominator by to get rid of either a radical, or you either get rid of the radical or the imaginary number. And what we do with conjugates, we have something like a plus bi, and we're going to end up with our conjugate is going to be a minus bi, because we know that a squared minus b squared, a squared minus b squared is going to be a plus b multiplied by a minus b. So you're going to find out that when we multiply a complex number by its conjugate, we will no longer have an imaginary value in that number. So let's go ahead and let's go ahead and put this to practice. So we're going to multiply, and we said here that we're going to find the conjugate. So I'm going to replace, instead of I minus 2, is going to be I plus 2. And then we're going to also multiply by I plus 2. And the idea behind this is that we want to always remember that we're multiplying by 1. Because when you multiply a number by 1, the number does not change, it stays the same. So when you have I plus 2 divided by I plus 2, you're multiplying by 1. But then we're going to use that I plus 2 to get rid of the imaginary number from the denominator of this expression. So we'll go ahead and continue to simplify. So we have 4 minus 3i multiplied by I plus 2. And then we have I minus 2 multiplied by I plus 2. So we'll go ahead and FOIL. That's the method we're going to use here. So we'll FOIL. So we're going to multiply 4 by I. So 4 multiplied by I is 4i. Then we're also going to multiply 4 by 2, which is going to give us 8. Then we're going to multiply negative 3i by I. We get negative 3i squared. And then we have negative 3i by 2. We have negative 6i. So that is the numerator. For our denominator, what we're going to do is, because we know that a plus b multiplied by a minus b is going to be a squared minus b squared. So this is going to give us a squared is going to be I squared minus b squared is going to give us 4. So let's go ahead and continue to simplify. So 4i, we're going to group all the common terms together. I always like to put the number, with the highest exponent, the part of the expression with the highest exponent at the beginning, and then we reduce the exponents as we go towards the right. So this is going to be negative 3i squared, then plus 4i minus 6i plus 8 divided by I squared is negative 1, and then we have minus 4. So let's continue to simplify. Negative 3i squared is negative 3 multiplied by negative 1, because remember I is the square root of negative 1, so I squared is equal to negative 1. So we have 4i minus 6i, that's going to be minus 2i, and then plus 8, and then we're going to divide by negative 1 minus 4, that's negative 5. So let's continue to simplify. Negative 3 multiplied by negative 1 is going to give us 3. And then we have minus 2I plus 8 divided by negative 5. And then one more, I think we should be able to simplify it now. We're going to group common terms together. Whenever we like to write our complex numbers, we like a plus bi. So that means that the constant term comes first, and then the imaginary term comes second. So this is going to be 3 plus 8 minus 2I divided by negative 5. And we're going to simply have 11 minus 2I divided by negative 5. And the best way to write this as a final answer is negative 1 over 5 multiplied by 11 minus 2I. This is a perfect answer. So are there any questions on this? So I know this can be very involved. This is an Algebra 2 topic. If you're in Algebra 2, this is a topic that you would want to be very familiar with, because once you get past Algebra 2 and you take a course like pre-calculus, this is something that you want to make sure you're very, very comfortable doing. Okay, so let's go to the next question if there are no questions. What is the equation of a line that passes through the points -1, 3, and 4, 2? What is the equation of a line that passes through the points -1, 3, and 4, 2? Okay, so we have this question here. This is grade 7, grade 8, and then Algebra 1 type of question. And so let's go ahead and try to answer this. We have the method for this is actually y minus y1 equal to m and then x minus x1. And here your m here is your slope. Your m is your slope, so your m is going to be y2 minus y1 over x2 minus x1. And so you can actually rewrite this formula such in this way: y minus y1 equal to y2 minus y1 over x2 minus x1, and then we have x minus x1. Just pay attention to the numbers or the variables here with the subscript are the ones that subscript is like a number on the below the letter that you're writing, so it's a number right under it. So that is the one that we're going to use for the points. The y and x are just going to be standard variables that we use in algebra. So let's go ahead and answer this, then we'll get to a question that for the younger grades. So we have y2, y minus y1. So I'm going to use this as my x1, y1, x2, y2. So we're going to have y minus 3 equal to, so y2 minus y1, so that's going to be 2 minus 3 over x2 minus x1. 4 minus negative 1, and then we have x minus negative 1. So we have y minus 3 equal to 2 minus 3 is negative 1 over 5. And then we have x plus 1. So some may be okay with you writing it this way, but you can go ahead and simplify. So this is going to be y minus 3 equal to negative 1 over 5x minus 1 over 5. And then we will go ahead and add 3 to both sides. So y is equal to negative 1 over 5x, and then we want to figure out what negative 1 over 5 plus 3 is. I'm going to rewrite 3 as 3 over 1, and so I'm going to rewrite this as negative 1 over 5. Actually, let's use our cross multiplication method. So I'm going to use the cross multiplication method. I'm going to multiply up this way and multiply up this way. So we're going to have negative 1 multiplied by 1 plus 3 multiplied by 5 divided by, we multiply across, 5 multiplied by 1. So this is going to be negative 1 plus 15 over 5, which is 14 over 5. Whenever you're dealing with equations, you don't have to write it as a mixed number. It's not really required. So this is negative 1 over 5x plus 14 over 5. That is the equation of that line. That is the equation of the line. Any questions on that before we go to our topic on, we're going to go to our topic for 6th graders and 5th graders. And maybe some 4th graders should be able to do it as well. I want to remind you all that I know some of us are getting ready for the SAT, the ACT. So on Saturday we'll be kicking off our new session for the SAT and the ACT. It's going to be very focused on helping students get ready for the test. We're going to do a lot of practice questions, practice problems that we'll actually go ahead and use some past exam questions that students can benefit from, so they can at least know what type of questions to expect, the structure of the questions, because most of the time students that don't do well in the ACT or the ACT, it's not because they don't know what the content is. For the most part, it's because they don't understand how to approach the exam. So for the next 6 weeks, we will, starting on Saturday, we will be going through this and showing you how to approach the SAT exam and the ACT exam as well. So if you need to, all right, Anastasia, good job. So if you're preparing for the exam coming up towards the end of the year, we'll be here to help you and to make sure that you can get into the school of your dreams, the school that you have set as your goal. So that's what we're here for, and I look forward to you all joining us, and we are very excited when we see students accomplish their goals. And so that's what we really want to see happen as you work with us to prepare for your SAT or your ACT. Okay, so let's get one more question here. A bakery uses 14.88 pounds of flour to bake 1.6 pounds of cookies. How many pounds of flour will be needed to bake 1 pound of cookies? Anastasia, that's very well done on the last question. That was very well done. So a bakery uses 14.88 pounds of flour to bake 1.6 pounds of cookies. How many pounds of flour will be needed to bake 1 pound of cookies? I'll give you some time to try to answer the question, and then we'll take it from there. 14.82 is an answer that I see here, 14.82. So think about the question. I want you to think about it this way. So a bakery uses 14.88 pounds of flour to bake 1.6 pounds of cookies. How many pounds of flour will be needed to bake 1 pound of cookie? 1 pound of cookies. How many pounds of flour are we going to require to bake 1 pound of cookies? Are we going to, the question you need to ask yourself is, are we going to multiply, divide, add, or subtract? And this is, we're working with decimals. So are we going to divide the decimals? Are we going to multiply the decimals? How would you be able to tell whether we should, well, how can we tell whether we should be dividing? Now we need to ask ourselves a few questions. What do we know? What don't we know? So let's start from what we know. I'm trying to guide you to get to the answer or to the approach to the answer. So we know, let's draw a small little table here. Know, don't know. So what we know is we need 14.88 pounds of flour. 14.88 pounds of flour, and then we also know we're going to get 1.6 pounds of cookies. What we don't know, we also know that, that's all we know. We know that we're going to have 1 pound of cookies. 1 pound of cookies, but we don't know how many pounds of flour. So what I want you to always think about is, for the item that is unknown, you have to ask yourself what you know and what you don't know. Are you increasing or are you decreasing? So we're going from 1.6 pounds of cookies to 1 pound of cookies. So we're reducing the quantity. So that means whenever you're having to reduce, you have two choices. It's going to be either subtraction or division. We're going to either subtract or divide. But in this case, because we don't really have, because we're looking at the amount of flour per pound of cookie. The amount of flour per pound of cookies, that's just going to be a division. So what we're going to do here is we're going to simply divide 14.88 by 1.6. 14.88 divided by 1.6. Now, how do you go about that? The easiest method to answer this type of question, you have two ways you could look at it, but the method I like the most is to go ahead and remove the decimal from the denominator or from the divisor. So to do that, we're going to move the decimal 1 unit to the right. And so when we do that for the divisor, we have to do the same thing for the dividend. So we're going to move it right here as well. So what we now have here is 14.88. So let's go with 148.8 divided by 16. So we're going to go ahead and just perform this division. How many groups of 16 are there in 148? Okay, very good, Jaden, very good. Very good answer. So we have 9 groups of 16, so that's 9 multiplied by 16 is 144. We're going to subtract. Ignore the decimal for now. We have 4 here, and then we bring down our 8. How many groups of 16 in 8? We have 3. 3 multiplied by 16, we have 48. So we're going to subtract here. We have a remainder of 0. Now, how do we know whether to put a decimal or not? So what we're going to look at here is in our new dividend, which is the number inside the division symbol, we have just one digit after the decimal. So that means that we should have only one digit after the decimal. Here, our decimal is right here. Our decimal is right here, so we're going to move it 1 digit to the left. So we're going to end up with 9.3 pounds of flour for 1 pound of cookies. So 9.3 pounds of flour for 1 pound of cookies. Are there any questions? Are there any questions? If there are no questions, I want to remind you of a few things that we covered today. I want to remind you of the fraction book. It's a fraction workbook, and this is everything you need to know about fractions. I actually had a grandparent purchase it, and it was like, wow, I wish I had this when I was learning fractions. It would have been a lot easier because this is so easy to follow. So those are the types of reviews that we're getting so far on the book. So I encourage you to just go get it, because fractions, as you have seen some of the things we've done today, fractions is something you can never run away from. If you run away from it, it will catch up to you. So what we want to do is make sure that you never ever think that you have to run away from it. So with this book, you're going to learn every tip, every strategy, every technique that is out there that you can use to solve fractions. And what we've done is we've especially introduced you to the techniques we've seen students use to overcome all their fears of fractions. So I encourage you to go get it and make sure that fractions no longer becomes an obstacle to your enjoying your math lessons. The other thing I want you to remind you of is our SAT ACT program starting on Saturday. It will be at 3 p.m. Central Standard Time. It's going to be over Zoom, so that means it's available to you regardless of your location. So 3 p.m. Central Standard Time is going to run for about 6 weeks. We're going to focus on techniques, strategies that you need to have in your back pocket as you get ready to take that test. I believe some are taking some tests in November and some are taking a test in December. So we want you to go there feeling equipped with all that you need to answer those questions. And then finally, we have free sessions that are available to students from Mondays through Thursdays. I know for sure on Thursdays we have all high school material. Monday through Wednesdays we have from about grade 1 all the way to grade 8. And some days we have 2 sessions. So if you're interested, go on our website, just fill out the contact form, let us know you're interested so we can send you the Zoom information. Otherwise, you can just send us an email, info@matheast.com. Let us know you're interested in joining those sessions. We'll send you the Zoom information. These sessions were actually set up so that students that need some help with homework in the evenings after school and maybe cannot get to someone who can help them, you have an opportunity to work with tutors that can help you answer your questions. All the tutors that we have for these free sessions have their engineers, so they can really help you with your math. If you have some science questions, I'm sure they'll be happy to answer some of them for you. And if you don't like the group sessions or group setting and you prefer maybe a private session for yourself, we also have that available. Go ahead to our website, our website matheast.com. You can also email us at info@matheast.com and let us know which of these you're interested in. At the end of the day, we want to make sure that all the students that come through our program or that we interact with, whether it's through our YouTube live sessions or our Zoom sessions or our private sessions, our goal is to see you all become very successful in what you're doing in your academics. And we have a goal of helping 5,000 students improve their math grades at the end of this school year. So we have some ways to go, but we don't have a lot of time. So please let all your friends know that this is an opportunity that is there for them to improve their math. And so we look forward to hanging out with you again next week. If you have any questions, please let me know, and we can answer in the last few minutes that we have before we end the session. If you have a topic that you're struggling with in school, you need some quick help with, we're here to help you. And don't forget, subscribe to our channel. We have lots of videos. We have over 400 videos focused on different math topics from elementary school. We're looking at things like even learning how to add and add decimals, fractions. In addition to the book, you will be able to see this. You'll be able to see a video of all these techniques being put into use. So that is an opportunity for you as well. Subscribe to the channel. You'll be notified whenever we go live. Well, we will be doing some other things in the future where we, have like pep talks and all of that in the future. So it's not just going to be only math. We're going to do other things that, we know students are going through right now, whether it's just to encourage you about, what is going to, the amount of work that you're going through, the things you're going through as an online student or virtual student or whatever the case may be. We'll be doing some of that to tell you some of the things we've done with our children, and also some of the things that we've seen other parents have shared with us that have worked for them. So we want to just keep doing that to make sure we have a vibrant community of parents, students, and learners. So we look forward to you joining us again next week. Have a wonderful Sunday and have a blessed week. We wish you the blessings of the Lord as you go through your week. Thank you.